So let's do another example. Let's imagine that we've got a line of charge and we've got a cylinder enclosing part of that charge. And I want to know what's the total flux through the edge of the cylinder. Okay, so you need to know a couple things. So let's say that the line of charge has a lambda, or linear charge density of 4.45 microcoulombs per meter, and let's say that the cylinder has a length of 16.1 centimeters, and it has a radius of 4.1 centimeters. Okay, so what do we do? Well, this is simple. We know that the total flux is the enclosed charge over epsilon naught. Well, how much is the enclosed charge? Well, the enclosed charge is the charge due to that part right there, and so the charge is going to be lambda times L. Okay, so that's going to be equal to 4.45 times 10 to the minus 6 coulombs per meter, because it's microcoulombs per meter, times 0.161 meters. And so the enclosed charge comes out to be equal to 7.16 times 10 to the minus 7 coulombs. And so we take that and we plug in up here. So that's going to be 7.16 times 10 to the minus 7 coulombs divided by 8.85 times 10 to the minus 12 of coulomb squared per Newton meter squared. And so what we find is that this is equal to 8.10 times 10 to the 4 Newton meter squared per coulomb. Okay. And so again, we avoided a very nasty integral. Applications of Gauss's law are a whole lot easier than anything that we did in chapter 22. So you can sort of see that chapter 23 is going to be somewhat of a respite from what you were doing in chapter 22.